In this video, we will dive into how arrays work in C. Here is a brief overview of the topics we will cover in this presentation. As introduction, what is an array, syntax of an array, types of arrays, array initialization techniques, examples of arrays, character arrays and strings, advantage and disadvantages of arrays, uses and applications of arrays in C. Introduction. Managing large amounts of related data efficiently in any language is a common challenge, and C is no exception. This is where arrays in C programming come into play. They provide a powerful way to group and handle multiple values of same type under one name, making your code cleaner and more organized. Whether you are working with numbers, characters, or other data types, arrays in C help streamline operations like sorting, searching, and iteration. So here we will discuss everything you need to know about arrays in C, from their syntax and types to practical examples and common mistakes. What is array in C? An array is a collection of multiple values of same data type stored together under a single variable name. Instead of creating a separate variable for each value, you can use an array to store and manage them efficiently using index numbers. These index numbers starts from 0, allowing easy access to each element. Arrays are especially useful when you need to work with lists such as marks of students, temperatures, or items in a menu. Now we can see the basic syntax for declaring an array in C language. So data type, array name, within square bracket, array size. Data type is nothing but the type of data. For example, int, float, character. Array name, it is any valid identifier. It can be any valid identifier. Array size, it is number of elements. It must be a constant or a macro. For example, int numbers of 5. It explains it is an array of 5 integers. Float squares of 10. It explains it is an array of 10 floating point value. Char letters of 26. So the meaning is it is an array of 26 characters. And we have to note that when you declare an array, memory is allocated for the specified number of elements. Right? The next comes, and the meaning is the array allocates space for 5 integers and initializes them. Right? Next comes accessing elements. For example, number of 2, numbers of 2. The meaning is numbers of 2 is this accesses the third element in the array named numbers. So arrays in C are 0 indexed, meaning the indexing starts at 0. So numbers of 2 indicates the item 30, the value 30. So the numbers of 2 refers to the value 30. So the output is 30. When I'm using this numbers of 2 in print statement, my output is 30. Right. Next, we can see an example for one-dimensional array. Here, the first line indicates preprocessor directive. The second line, int main, this is a main function where program execution begins. And the next line is int marks of 3 having 3 values 85, 90, 95 within curly braces. So this line declares an array of 3 integer named marks. It initializes the array with the values. So marks of 0 is 85, marks of 1 is 90, and marks of 2 is 95. Next comes a for loop. for int I is equal to 0, I less than 3, I plus plus. The meaning is this is a for loop that starts with I is equal to 0 and runs while I less than 3. It increments I by 1 in each iteration. So the loop will run 3 times for I is equal to 0, 1 and 2. Next comes a print statement. This line, the print statement having marks of I. This line prints the index I and the value stored at max of I. So the percentage %d in print statement, printf statement is a placeholder for integers. And you have a /n. This adds a new line after each print statement, after each print. So percentage %d is a placeholder for integers, and /n, this is a new line character. It adds a new line after each print. So mark of 0 is 85, marks of 1 is 90, and marks of 2 is 95. The last, a return statement. So this ends the main function and returns 0 to the operating system, indicating that the program ran successfully. Next comes a two-dimensional array. A two-dimensional array in C stores data in a table-like structure using rows and columns. It is often used to represent matrices. So the way we declare two-dimensional array, int matrix 2, 3, meaning 2 rows, 3 columns. So that's the line int matrix 2, 3. The meaning is it defines two-dimensional array, right? Two-dimensional array. The type of element is integer. The name of the array is matrix. And meaning is it is able to declare 2 rows and 3 columns. So this creates a grid-like structure in memory. Next comes the initialization of two-dimensional array. Here, declaring and initializing two-dimensional array, that is int matrix of 2, 3, meaning initializing two-dimensional array called matrix with 2 rows, 3 columns with values initialized. The values are 1, 2, 3 in row 0, 4, 5, 6 in row 1. So 2 rows and 3 columns. Next come accessing elements. Here I have a printf statement. Matrix 1, 2 accesses the elements in row 1, column 2 of two-dimensional array matrix. So in this array, the element being accessed is matrix of 1, 2, which is the value 6. The value 6 is accessed. Matrix of 1, 2, the output is 6. Here is a program, a sample for two-dimensional array. This program creates two-dimensional matrix. It fills it with the values 10, 20, 30 and 40. Then it uses a nested loops to print each element with its rows and column indices. Next comes a multi-dimensional array. In C contains more than 2 dimensions like 3D or 4D arrays. These are rarely used but helpful in special cases like 3D games or image processing. So the declaration in multi-dimensional array, for example, int cube 2, 2, 2. The meaning is it defines 3-dimensional array, right? That means layer 1, row 0, column 1, right? Initialization, int cube of 2, 2, 2 having 8 values, right? And the way we access the elements in multi-dimensional array, cube of 1, 0, 1, the meaning is layer 1, row 0, column 1. So it accesses the value 6 in the matrix. techniques. Right. Next, array initialization techniques. In C, when you declare an array, you can assign a values to it using a different initialization method. So the common techniques are, the first one is compile time initialization. You assign values to the array at the time of declaration. For example, int numbers of 5 having 10, 20, 30, 40 and 50. Values are stored in order. If fewer values are provided than the size, remaining elements are set to 0. The next method is runtime initialization. This is done using loops. You can assign values to each element using a loop, especially when taking input from the user. For example, int n of 3. So this line declare array named n that can store 3 integers. The next line, it is a for loop. It starts a loop that runs 3 times for I is equal to 0, 1 and 2. And next comes a scanf statement. In each iteration, scanf reads an integer from the user input. The inputted integer is stored in n of I. The ampersand is the address of operator, providing the memory location of n of I. So scanf knows where to save the input. Now we can see an example of array, how to print elements of an array, right? A program to print elements of an array. Here the first line, it is a preprocessor directive which includes standard input-output library. Next, integer inside the main function. The first line is int numbers of 5 having 10, 20, 30, 40, 50. So the line explains, declares an integer array named numbers with 5 elements. Next, and the values are initialized. The arrays are initialized with values. So integer, int, numbers of 5, 10, 20, 30, 40, 50. It declares an integer array named numbers with 5 elements. Initializes the array with values. Numbers of 0 is equal to 10. Numbers of 1 is equal to 20. Numbers of 2 is equal to 30. Numbers of 3 is equal to 40. And numbers of 4 is equal to 50. Next comes a for loop. Here the loop iterates from I is equal to 0 to I is equal to 4, 5 times. It allows you to access each element of the array using the index I. And you have a print statement that prints a current index I and the value stored at numbers of I. Here you have a percentage %d. In printf statement you have percentage %d. It is a placeholder for integer and a new line character which moves a cursor to a new line after printing. And the last one, return statement, which ends the main function and returns 0 to operating system, indicating the program executed successfully. So the explanation is, you have a simple loop used to access and print each array element. Another example, a program to reverse an array. Here the first line again includes standard input-output library, and inside the main function you have an declaration, array declaration named ARR with 5 elements, and the values are initialized. Arrays are initialized with values. And you have a print statement that prints a text reversed array. Then you have a for loop starting from I is equal to 4, that is the last index, down to I is equal to 0, that is the first index. So I minus minus means the loop decrements I by 1 each time. So this loop runs backwards through the array. And the next statement is printf statement. It prints the current element of the array at index I. And percentage %d formats the integer followed by a space. So all elements are printed on the same line separated by spaces. And the last statement returns 0, which ends the main function and returns 0 to operating system, signaling successful execution. And the explanation is, it prints array element in reverse order using. Next comes character arrays and strings in C. A character array is a sequence of characters stored in a contiguous memory location. So in C, strings are represented using character arrays terminated with null character. which tells the compiler where the string ends. Here, the next comes declaring a character array. We have two methods. Declaring a character array, we have two methods. The first method using a character list. It must include a null character at the end to make it a valid string. Size must be 1 more than a number of characters to accommodate the null terminator. For example, char, it is a data type, name of 6, right? And within curly brace, the value is initialized. H, E, L, L, O, and the last one is a null character. So the meaning is it must include a null character at the end to make it a valid string. The size must be 1 more than the number of characters to accommodate the null terminator. The second method is using string literal, which is recommended. It automatically adds null character at the end. It has easier and cleaner syntax. For example, char, name, size is not specified, and a string within double quotes. Hello. The next comes how to initialize and print the strings. So the code will print the value of city as Delhi. So the Delhi is initialized to the array city, and in the print statement I have used a %s, a formatted string that will display, that will print the value Delhi for the variable city. Next comes reading a string from user. So using scanf, we are able to read a string, but it stops at a space, right? The next, using fgetS, it reads a full line including spaces. The syntax is fgetS. I have 3 parameters, name, 20, standard in. And accessing individual characters, char, a string of is equal to a C language within double quotes. When I print str of 2, and the formatted string I have used is %c, then it will display the value L from the string. Next, the advantages of arrays in C. The first one is efficient. It is efficient data storage. Advantages of arrays in C. The first one is efficient data storage. Here arrays allow storing multiple values of same data type using a single variable name. And the second point is indexed access. You know that elements can be easily accessed, modified or iterated using index number, that is zero based indexing. And the third one, reduced code complexity. You don't need to declare multiple variables. One array can hold hundreds of values. Next come easy looping and traversal. Array can be easily processed using loops, making operations like printing, summing or searching simpler. The next one is improved memory management. So array use a continuous memory, which helps in faster data access and better memory locality. Next comes useful in algorithm. Arrays are widely used in sorting, searching, matrix operation and many algorithms. And the next point is foundation for advanced structures. So array form the basis of more advanced data structures like strings, matrices, stacks, queues and linked list. And the last one, cleaner and organized code. So it helps organize related data under a single name, improving readability and maintainability. Next comes disadvantages of array. The first one is fixed size. Once you declare, the size of an array cannot be changed during program execution. The second one, static memory allocation. Memory is allocated at compile time. which may lead to inefficient memory usage if the size is too large or too small. No bound checking. C does not check whether an index is within array limits, which can cause unexpected behavior or segmentation fault. Only homogeneous data types. Array can store elements of same data type only. For example, all int, all character. The next disadvantage, no built-in dynamic resizing. You cannot grow or shrink an array at runtime without using dynamic memory. The next one, no built-in insertion or deletion. Inserting or deleting elements need a manual shifting of elements, unlike in higher level data structures like list. And the last disadvantage, wastage of memory. If the allocated size is larger than needed, the unused memory is wasted. Next slide is uses and applications of arrays. Storing multiple values. To store a collections of values like marks, price, score using a single variable name. Second point, handling tabular data. Arrays are used to represent matrices, tables and grids in a structured format. Next, string handling. Arrays of characters are used to store and manipulate strings. Then sorting and searching algorithm. Arrays are essential in implementing algorithms like bubble sort, binary search, merge sort, etc. A loop-based operation. Arrays make it easy to perform repetitive operations on data using loops. Storing input data. Arrays are commonly used to make multiple inputs from user and store them temporarily. Next, mathematical computation. Arrays are used in vector and matrix calculation, statistical analysis, and numeric simulations. Next, buffer handling. Array can be used as buffers for reading or writing data in file handling and input or output operations. Then, simulating a real-world collection, like storing student names, temperature of the week, scores in a game, etc. The next one, implementing data structures. So arrays are the foundations of stack, queues, heap, and hash tables. And the last one, storing command line arguments. So it is an array of string passed from the command line in main function. Thank you for your time and attention.